started developing Statcrunch many years ago, so it may be new to you guys, but this package has been around for a while. I guess 1997 was the first release, and the National Science Foundation supported it for quite some time, and Pearson took it over in 2009, and we've been working with them ever since. And thanks to them for putting together the webinar today. I know it's sort of an odd environment to ask questions, but please feel free to you can interrupt me if you want, or you can send a chat message to Erin and she'll interject. But if you do have any questions as I'm working through this, I'll be more than happy to answer them. I like to be as interactive as possible in this environment. But I know most people are a little bit standoffish. But so I thought I would just do a very basic introduction to Statcrunch, and then maybe show a little bit about how I'm using it in my own classroom as well, and then you guys can have some takeaways here, hopefully that might allow you to use it better in your own classroom. So in the Statcrunch, at statcrunch.com, you can load data sets, you can do surveys to collect data, and you can analyze data. And most people think of Statcrunch as a data analysis tool, but at the site we have lots of things, of course, built around that. So I'm already logged into the site here as myself, and if I go to the My Statcrunch menu, I can go to My Data, and these are all the data sets that I have loaded into Statcrunch. I've only got 447 of them, and several of these I'm actually using in my class this semester. I thought I would go with this Big Bend visitors by month. This is an interesting data set. And so this is what Statcrunch looks like, of course, when you open it up. It's, sort of a standard data analysis software appearance. And I thought I would show you a little bit about how it functions in the context of this data set, sort of working from right to left in terms of the menus here. So I'll start with the graph menu and show you some of the graphs that are available here. Actually, before I do that, I should tell you a little bit more about the data. So this is the number of monthly visitors visiting Big Bend National Park, beginning in 1979 and going all the way through 2012. Okay, so I haven't yet updated it for 2013. It's an interesting data set, a beautiful park in Texas. With this data set, under the graph menu, one of the things I've asked my students to think about is how they would characterize the number of visitors across the months. So how do they think about visualizing that and making some comparisons and telling a story, basically, with this data in terms of the number of visitors that typically come to the park in each month and how that changes over the year. So I'll go down and show you a box plot of this data. All right, so we might want to do a box plot of visitors here, and we might want to group the data by month. And I'll start here and come back and change some things in a second. So I know there can be a bit of a time lag, so I'll give you hopefully give it a second here so you guys can see exactly what I'm seeing. But so this is an example of this stacked box plots for this particular data set. You'll notice, first of all, that Statcrunch is smart. It recognizes months, so it orders the months correctly, January, February, March, and rather than doing it alphabetically and things like that. There are a few special orderings that Statcrunch recognizes, and you can identify your own orderings if you want to under the Edit menu. But I thought this was sort of an interesting picture. It's an interesting storytelling experience for the student. So we can clearly see here that the medians in these box plots, we see that it's sort of low in January and then increases from February and peaks in March, dips back down starting in April, May, and sort of bottoms out again in August when it's too hot to visit the park anymore. And then turns around and increases all the way up through November, and then I suppose December nobody wants to travel and it goes back down a little bit again. So some interesting features here in this box plot, or this sequence of box plots. Also, you'll see here that March also has the most variability if you look at the interquartile range across all the months. So it's the highest but also the most variable month as well. And the way I used this data set in my class this semester, I actually used it on an exam. I had my students, first of all, just do a box plot of all the visitor data. And I asked them to evaluate where 40,000 would fall in terms of the number of monthly visitors. And of course, it's clear from looking at this simplified box plot here that that would be in the upper quartile. And then I asked my students, if you had 40,000 visitors in March, would that be a good March? Supposing you sort of work for the Parks Service, I suppose, would 40,000 be a good number in March? Well, it's in the upper quartile of all visitors. When we break it out by month, we see that 40,000 is actually it's in the second quartile in March. So it wouldn't necessarily be a very good March if you had 40,000 visitors. So just that sort of thinking about seasonal adjustment and things like that are some things I was working with this particular data set. All the graphics in StatCrunch are interactive, so if we want to identify the years in March where the number of visitors was high, we can draw a little rectangle around that upper quartile, and then we can go back over to the data table, and we can go down and see exactly when those months occurred. So we'll see 1993, 94, 95. All those values are highlighted in the data table. And this works in both directions. You can turn off the highlighting by going up to the row label at the top. This is the shortcut way of doing it, and clicking on the row tab. That turns off all the highlighting. You can also go to the data menu, choose row selection, and deselect all if you want a menu approach. But just remember the row label there is a quick way to deselect everything. So it does go both ways. So if we want to know in December of 2012, December of 2012, we can click on the row number there, and we'll see that it's highlighted now over here in our plot. Hopefully my screen has not been shrunk so small that you can't really see that, but it's right at the median for December. So it's sort of right at the typical value for the number of visitors that we would see in December from 2012. Once again, I'll turn off all the row highlighting now. So that's just a quick look at the graphics, the interactive capabilities. What I've noticed is that the interaction makes a big difference. Students being able to brush graphs really draws some connections between the graphs and the data. I found that my students could answer questions like, is the histogram right skewed or left skewed, and things like that, and they sort of memorized the shape, but a lot of time my students didn't seem to understand how the data actually went into contributing to the graph. And this interaction, being able to brush elements within a graph, really draws that connection. It's almost, to many of my students, I think they felt like the graph just kind of came out of nowhere, and they didn't really understand in many cases how it was generated by the data. So
hey,
that's
Webster?
Yes. Mm-hmm.
Sorry to interrupt. I had a question from one of the attendees. Jeffrey Jones was asking if this data set would be available for instructors. Is this something you could share with the StatCrunch instructors group? Maybe talk a little bit about
absolutely. That. Yeah, sure. While I'm here, why don't I just show how you would share a data set?
Perfect.
Okay, so this is the new version of StatCrunch. Right? I like it so much better than the old Java version, which we had for years, and we just rolled this out this semester. So things do look a little bit differently. So even if you use the old version of StatCrunch, this may be something different for you. The eye icon down in the tool tray, that's what we call these icons down at the bottom, is the information about the data set as it's stored on the statcrunch.com site. So you see I'm the owner, Webster West. It's not shared with everyone, but I think what I'll do now is I'll actually share this data set with everybody. So I can edit the properties of this data set and share it in a variety of ways. So I can share it with my group, with my NC State group from this semester, and that's what I've done so far. But I'm just going to turn around and I'll share it with everyone. So everyone can now access this data set. And I'll update that.
Would you also maybe share it with the StatCrunch instructors group for folks who are part of that?
Yeah, I can do that. If you guys are in the instructors group, which is supposedly limited to just instructors at the StatCrunch site, I'll share it there as well. And so just to see what happens when we do this, I'll leave the data set tab for just a second, come back over to the sort of StatCrunch navigational tab. If I go over to Explore and look at data, we can actually find it here by searching on Big Ben. And there it is. Oh, in fact, I think I shared a previous version of it down here, so it's there twice. So there's no harm done. So that's the way that you can find this particular data set. And you'll find lots of data sets here as well. There are 17,716 of them, and that number seems to be increasing pretty rapid pace. I think we've had about 3,000 new data sets shared with everyone this year. A lot of people share data sets just with their group, just with their, typically a group is a class, but not always. A group can be formed around a topic or for a variety of reasons. Just a loose set of Statcrunch users. My group, I'll show you where that's at here. Here's my NC State Stat 101 group this semester, and a group's just a collection of data sets, results, reports, and surveys and things like that. So far I've shared 15 data sets total with my group. Students shared a result already, and then these are the surveys that I have them do in class. I do about one of these per class, and I'll come back and I'll talk about these in just a minute. I sort of want to save that for the end and get back and talk about the software for just a bit. All right, so here we are back over at the software. We now know how to share a data set and things like that using the information icon. And let's look at everything under the graph menu here. So under the graph menu, we've got everything from simple things like bar plots and pie charts to a more general charting tool so that you can chart rows and columns in a variety of ways, stacked and split columns and things like that. We also got your basic histograms, stem and leaf, basic distributional things, and then the box plot for comparing distributions, dot plot, means plot, which is the standard error of the mean plot, so you can look at and compare groups using that. Then you got your scatter plot. There's some tools for looking at association. You got scatter plot. A multi-plot is like a more general plotting tool, so you can plot numerous things on a single graph. A QQ plot for assessing normality. Index or time plot, so you can actually plot time series data in Statcrunch as well. As a matter of fact, why don't I just show you? This is a new feature we just rolled out yesterday. We added the time feature to this. So in this case, we start in January of 1979. So I want to choose the visitors column that I want to plot, and I'm going to plot it over time. And what I have here is month and year. And we're going to start in January of 1979.
Press pound 6.
And I'll go ahead and click compute.
Okay,
I'm getting some feedback here. All right, and so there's your time series plot with the dates and everything on the x-axis. So you can definitely see the seasonality here. It's a very interesting time series, actually. I teach time series as well, so I'm definitely going to come back to this data. So this is really our first foray in Statcrunch to doing some time series analysis, and that's something we're going to invest some time in. I personally think probably 70% of the world's data sets are time series, and at the introductory statistics level, we should probably do a better job of teaching some very basic time series skills. Some things, very basic things like seasonality and adjusting for it and stuff along those lines.
Hey, Web?
So this is yes.
Sorry, we have a question from Kristen Freeman. Is there an easy way to create a histogram with data in one column and frequency in another column?
No. Yeah. I mean, there's not a histogram with summary tool. I can sort of mimic that here. Let me go back over and find some empty rows in the data set. So suppose you had something like this. You had, let's see, 1, 2, 3, and so on. And then you had some counts like 30, 20, and 50. Is this the sort of format you're thinking of here? You can either chime in or text something back over to Aaron.
I can unmute.
Yeah, so
I'm going to unmute you as well, so if you feel like you want to chime in.
Yeah, so this would be what we call in Statcrunch summary data. And just to give you some idea, like if we thought of this as being categorical in a sense, we could do bar plot with summary. We could select a variable categories in var 4 and the counts in var 5. We could do something like this, okay? So that's not a histogram, of course. the problem with the histogram with summary is exactly how one would define the bins. And too often what I see, people want to work with this sort of thing. They want to say 1 to 9 as one bin, and then they want to do 10 to 19, something like this, and then they want to do 20 to 29. And I submit it's almost impossible to draw a histogram of that data. For one, the bins do not overlap, so there's got to be some awkward spacing between consecutive bins. It's also unclear exactly what endpoints are included in which bin, which makes a big difference when drawing a histogram. So I don't think there's a clever way of doing this correctly in all situations. So we had a request for that fairly recently, sometime this semester actually. But so it's been on my radar, but I haven't come up with a good way of really thinking about this particular problem. If you have ideas, of course, I'm always willing to listen, but that's the downside of trying to do it, I think. So you do have a bar plot that can sort of serve as a surrogate for that, but it's, of course, not really a histogram, so I wouldn't necessarily recommend thinking of it that way. Okay, so let's see here. So if there are no other questions about the graph menu, I guess I need to finish it out here. You can do pairs plots, which is a matrix of scatter plots. Word wall, that's a way of analyzing text data, like comments and stuff like that about a particular product or something like that online. You can, or tweets, a set of tweets. You can use the word wall to dissect and look at all the most commonly used words and look at some relationships between words and things like that. The map feature, you can map, do color-coded maps of the states. You can do maps of individual U.S. locations, and you can actually take any data out of the Statcrunch data table and plot it on a Google map. Statcrunch will do that for you as well. And the Facebook friend data application is a great example of how that works. Okay, so that's a real quick run through on the graph menu. Yes?
Well, I just had one question. Jeffrey Jones is working on his Statcrunch along with you because he highlighted the individual data in the box plots. And I forget 2 ways to unhighlight the individual data. Can you remind the group?
Yeah, the shorthand way is to always just click on the row label in the upper left-hand corner of the data table. That's the quick way to do it. The other way is under the data menu, you can go to row selection, and you can deselect all.
Great, thank you. He's also asking what Facebook friend data is. So I don't know if that's something that you'll get to.
Yeah, if we have some time today, so Facebook friend data is a Statcrunch app. So what it does is it pulls information about all your Facebook friends into Statcrunch and creates some nice summaries of that information. One of those summaries is a summary of the location of your Facebook friends, and it actually does all that on a Google map. It puts all the individual locations on a map, and it clusters them, and so if you're traveling to New York, you can click on New York in the map and see who you know in New York and things like that. So I can come back to that and try to show that at the end if we have some time. Okay, under the stat menu here, so what we have are basic summary stats that you can compute for columns and things like that. Just to give you a flavor here under the summary stats menu, I might want to compute the summary stats for visitors by month. And there I now have a nice table of all those results. I think one of the things you should notice in just this brief introduction I'm doing here today is that all the dialogues have a very similar look and feel. And the idea there is that students learn how to use one particular procedure. They can take that knowledge and translate it to another procedure. So, there's always, we go back to our box plot over here and choose edit so we can see our inputs. You can see that there's some strong similarities between these two dialogue windows for doing summary stats and doing box plots. And that's the same for procedures throughout the package. So these first 3 options where you select the columns that you want to work with, you can enter a where expression to filter out outliers, things like that, so to control the data that's actually going to be used in the procedure. And then there's the group by option. And those 3 things are very consistently used throughout the package. And then you have some more advanced options and detailed options for the individual procedures down below that. Okay, so there's our summary stats. By the way, you can choose a few more summary stats. The default ones here, you can also add sum, the interquartile range, the unadjusted variance, which is a divisor of n rather than n minus 1, and its cousin, the unadjusted standard deviation. You can do skewness, you can do kurtosis as well. They're not selected by default. You can also enter arbitrary percentiles if you want to compute percentiles for the various groups as well. And you can enter an expression for a statistic that you want to compute, like you might want to do mean of x divided by STD for standard deviation of x to get the coefficient of variation. So you can do a lot of different things here if you choose to. Also under the stat menu, the very first thing here is the calculators, and this is probably one of the things that Statcrunch is best known for. So we might want to look at the normal calculator here, and we can enter values here. And you always tell your students to do a graph when working normal problems, doing things along those lines. Of course, most of the time they don't do that. We always tell them you're more likely to make a mistake, and I found that to be very much true. So this calculator does the graph for them, unlike that awful table on the back of the textbooks. So if we want to know the 0.05 quantile here, we can actually just enter 0.05 and change this arrow to greater than or equal, and we get the 1.645. And something else that we just added this last yesterday is we added this option menu to all the calculators. So if you're having your students work some probability problems using these calculators, they can save an image of this calculator to their My Results folder, include it in a report or something like that if they're doing it as part of the homework. They can also copy it. So if you choose copy, you get a nice image now that we can right-click and copy, and we can paste into Word or something like that. You can also print it. That's another option. So you've got all these things now that you can do with the calculators. We hadn't had those all those options until yesterday, so we're kind of excited to put those in there. Of course, you can download it to your computer as well and do some things along those lines. These calculators are very useful. My students, these are the workhorses in my engineering stat class. They use these a great deal. Other things under the stat menu you can do, frequency or one-way tables, two-way tables. You can do something called an outcome table, which is for common delimited data that exists inside a cell. You can do your z-tests, your t-tests, your p-tests, variance tests, regression. You can do simple linear, polynomial, multiple linear, logistics, ANOVA, one-way and two-way, non-parametrics. So if you like to cover non-parametrics in your intro class, you can do that. These are exact methods as well, so it's a really nice development here. Goodness of fit, you can do chi-square normality tests, control charts, you can do those. You can also do resampling. I don't know how many people on the call are interested in doing resampling, specifically in the intro course, but I'm one of the people who's done some research into this and tried to think about how we could modify the curriculum to include things like randomization tests and bootstrapping and things like that. I guess I'm of the opinion that it's useful to do some of those things, but maybe not ditch everything that we currently do and do everything with a resampling approach. So this is a very general resampling tool where you can type in your own expression. You could basically bootstrap or randomize anything using this tool. We have some other options for doing this in a more sort of animated way that I'll show you in just a second. So under the data menu, you can load data. As I said, you can load data. You can load from text files. You can load Excel files. Pretty much any format can work with those two. And so you can load those types of data into Statcrunch. You can, of course, do row selection. There's some really cool features here, some interactive tools. So maybe we want to choose the visitors column here. And now we can actually, we've got a slider and we can adjust and see where the upper values now for visitors are selected, and you can see that those aren't, not surprisingly, in March and April and months like that. We've had those high number of visitors. So there's some really nice storytelling things you can do using these sliders as well. And there's category selectors that you can use there. Go back to that row label. You can compute expressions. So this is something I use a lot. You can type in an expression, or you can. We now have builders so that you can use this sort of interactive builder. So we might want compute an expression of visitors and then divide by 1,000. And then we click compute, and we've now got our visitors column over here in our visitors divided by 1,000 column in our table now. Something else that was added yesterday, so you can now resize these columns. If you put your mouse over the right edge of a column header in that first row, you can drag it out to make it bigger. So I'm certainly enjoying that feature myself now. Also under the data menu, you can simulate data. So, if you like to do things where you illustrate the central limit theorem or other statistical concepts, StatCrunch has some really nice tools for doing simulation and building those sorts of things very dynamically using the data table. So there's some very nice features there. You can compute the mean of 1,000 samples from a normal distribution with sample size 5 very, very quickly in StatCrunch. And do the same thing for varying sample sizes, illustrate the central limit theorem in just a matter of minutes doing that in a very concrete way that students can see in the data table. You can also sample from columns. That's yet another way that you can do resampling in StatCrunch. Or if you had a population actually in the data table here, you could take samples from that. You can create sequences from 1 to 100 by 3 and stuff like that. You can split, stack, bin, sort, rank, transpose data. You can do all sorts of data manipulations here. So it's a pretty sophisticated set of capabilities here in terms of maneuvering data and working with data in raw format. Under the edit menu, you've got your standard cut, copy, paste, select all. For columns, you can insert, delete, and move. Rows, you can insert and delete. We haven't got the move worked out yet. You can change the display precision in the data table. This is something we just added yesterday, so you can specify the number of significant digits or the number of total digits in terms of the way that the data is displayed in the table. You can change the fonts, the orderings. This is what I was talking about earlier. These are the default ones that StatCrunch knows about. You can add your own ordering. If you like low, medium, and high, you could add that ordering here so that your data would always be displayed in that order
hey, Wes.
as well. Yes.
Sorry, quick question from Joe Joyner. I think I'm pronouncing his last name correctly. Are the StatCrunch menus slightly different on a Mac in comparison to a PE? Or might I be seeing the old version still since I'm accessing via my StatLab?
If you are using IE8 or earlier, so anything below IE8, IE8 is not HTML5 capable, so you can't run the new version of StatCrunch in IE8. So what happens is we sniff that out, we'll automatically direct you to the old Java version. And there are some subtle differences, Macs and PCs with that old version, but with the new version, the menus are identical, regardless of what platform they're using.
He is using IE9.
Okay, with IE9, you should be seeing the new version. Yeah. So you should be seeing something that looks identical to what I have here on my screen.
Could it be a matter?
I'm sorry?
I was going to say, could it be a matter of changing preferences within my StatLab?
No. I mean, you do have the choice of using the. Oh yeah. Now, if you set up StatCrunch to use the classic version, let me go over here and show you what I'm talking about. Under StatCrunch, you can go to My Preferences, and by default, everybody's set to be the new StatCrunch, but you can actually go in here and choose to use the classic or the Java version if you wanted to. And I don't know if you may have perhaps done that, but that would be the only way to do that if you're using that.
He's saying he has a Mac with Mountain Lion, so maybe this is something we can explore offline if he's still not seeing the correct version.
Yeah, sure. We can certainly have a talk about that once we're done here. All right, hopping back over here to the data again. So I think we went through everything here. Color scheme, something else on the edit menu. So we got a couple new color schemes that you can choose from in the graphs. You don't have to use the standard one that we have, and you can create your own color schemes as well. The StatCrunch menu oftentimes overlooked, but all of our session results, so our bar plot, our time series plot, and all that, we can go back and access over here and pull them back up. We can show all of them at one time if we wanted. And then we can also go back over here and hide them all as well. So it's a quick way to toggle that back on and off. The applets here are the big thing I think that people sometimes overlook in this menu. What these are basically, the name applet was originally derived for little Java applications that ran in the web browser. We kept it here even though things aren't Java anymore. But these are little interactive demonstrations that are designed to help people teach statistical concepts. So we've got, I think, almost everything covered here. We're just missing a couple from the old version that we're still working on, a Bayes applet and a contingency table applet. You can see here confidence intervals, hypothesis tests, mean versus median. There's some things here for teaching that. Some demos that let you explore how the parameters affect the distribution. Correlation by eye, regression by eye. These are things that sort of visually help students learn how to identify certain correlations and explore the regression relationship. We got some resampling applets as well, the classic sampling distributions applet, and simulation applets for simulating things like the birthday problem, coin flipping, die rolling, poker hands, raffle winnings, and earn sampling, and things along those lines. So I'll show you the sampling distribution applet. So let me pop it up here. This has existed in Java form for a long time. I've had my own Java version of this out there for about over a decade, I'm sure. And this is a new version that doesn't require Java, so this is something that you can use and not have that ugly Java requirement. So what we can do here, we're taking samples of size 2 from our nice uniform population. We can take one sample of size 2, and we see that the 2 sample values then are dropped into the middle graph. And the mean of those 2 is what we chose here for our third graph. That's just the statistic we're studying. So we see that in green down below there. And then we can do it 5 times. So we're repeating that process of sampling 2 from our uniform and computing a mean. And we've now done it a total of six times. And then we can really let it rip, okay? So we can start sampling thousands of times. So we're now up to 10,006. You start seeing the triangular shape of the distribution for the mean coming up here. Up to 25,000. So you really see the distribution as we're working with it here. So then we could bump up the sample size, make the sample size 10. And once again, do the 1 time. It's always good to step, walk, and run. So let students get a very good idea about what you're doing by taking it slow. We took a single sample of size 10 and computed the mean of the 10 values in the middle to get the 1 on the bottom. And then we can do this 5 times. So there's 2 more samples of size 10, 3 more, 4 more, and then 5 more. So we got a total of 6, and now we can really start ramping it up. So we can already see here we had a triangular distribution for a sample of size 2 for the sample mean, and now we have something that's looking much more normal, even with a sample size as small as 10 when we're sampling from this uniform distribution. So it's a nice way you can illustrate the central limit theorem. Going back here and editing the inputs, you can also specify a second statistic. For example, we might want to look at the median as well, compare the mean and the median. And we can come over here and simulate those. So the red now is the median, sample median. The green is, of course, still the sample mean. The 2 are actually the same when you have samples of size 2, but if we make the sample of size 10, you can start thinking about which one of them is better at estimating the center of that uniform distribution. The center in this case is 25. We can see that the mean has much less variability than the median in terms of estimating that center point for our distribution. Now, I always struggle a little bit with telling students when you should use the mean. We talk about if there's any skewness or outliers, we should use the median as a measure of center or typical. And it's hard to actually come up with, at an introductory level, a good reason for when you should use the mean. And I use this applet for this very purpose. So when things are symmetric, the mean is better at estimating the center than the median is in most situations. So this is one way of conveying that point, not requiring the students just to believe some fact without any justification. Okay, so there are tons of applets here. If you haven't looked at this applet menu, I highly would suggest that you take a look at it. There's some really nice things here. I'll show you one more. Let's do a histogram with sliders of this visitors column. What this allows us to do, we can interactively change the bin width and see how that affects the histogram. In this case, it's going to be right skewed no matter what. But you do get a slightly different shape of the distribution as you move it around. You can also change the starting point of the distribution as well. So you can really interactively play with the binning structure for the histogram and see how it changes the picture. And there are some great examples on Statcrunch where the picture changes completely if the bin structure changes. So, you know, one of the things I always tell my students is it really matters you never look at a single histogram. Don't trust Statcrunch or any package to tell the right story for you. This is something you would always want to experiment with if this was an important decision you were making looking at the data. All right, so as I said, definitely check out that applets menu if you haven't already. A couple more coming out probably next week. That'll finish up our listing for now. And if you have other ideas for applets, of course, we're always willing to listen to those as well. Okay, so that's a real quick run through on the software. I'll stop just for a second. If anybody has any questions about the use of the software tool itself, shoot them on over to Aaron. And if we don't get any, I'll move on and talk about some of the other site features.
Thanks, Brett. Yeah, I'll just remind folks, too, if you do have questions, I've muted everybody, but please feel free to send me a private chat or chat to the group with any questions for web, and I'll interject.
All right. So coming back over here to the navigation tab here, going back to the Statcrunch site, there's some things I just want to sort of point out to you. So we talked about the data sets, the fact that you can share them with everyone, and there's a great resource, a huge number of data sets that you can look for there. But the other thing you might want to know about the site is the survey feature. So you can actually collect data by constructing surveys at Statcrunch and then analyzing the data that comes out of that using the tool that I just showed you. So we're running a survey here on the main website now, the U.S. government shutdown, and basically asking people if they believe it's a serious thing and who's responsible and what political affiliation they have and their age and years. So we are constantly collecting data and then sharing this data with the Statcrunch users. So we'll run this survey for a week or two and then roll it over and share the resulting data. See, we try to always do things that are timely so that you get something that's interesting at that moment in time, something that will hopefully pique the students' interest if you were to use it in the classroom. Of course, this is all sort of survey data, and it's not a random sample. You don't necessarily do inference with it. There's some really great descriptive things. These data sets, we collected some very rich data sets for doing descriptive things. And honestly, I think it's things that we should spend more time on at the introductory level. We need to teach students how to be better storytellers with data. I mean, odds are the average student at the introductory level will never, ever get a random sample or get the results of a randomized experiment to analyze. And the most of the data that's out there, 99% of the data that they can readily access that might be of interest to them, is really not suitable for inference. There's so many more things that we could do, and at the descriptive level, I could basically almost fill up the entire course with visualization and other techniques for manipulating and organizing and displaying data. I would really like to see us move more in that direction. So we constantly collect this data. We put it out there so you can pull it up and analyze it in the classroom if you want, use it as examples. As a matter of fact, if you go here to the Explore and look at the data sets that are explored, this is one that we just turned over yesterday. So this is what's the ideal summer temperature. I want to show you this data set just for a moment here because this is an interesting one. So we got the ideal temperature that the respondent reported in one column, their gender and their age in another column. And let me just show you a graph, a histogram here of the ideal temperature that people provided. And so that's what you get. That's what people entered. So it's interesting. So can anybody want to venture a guess here why we have this mode down here in this between 20 and 30, or it looks to be just south of 30 there where the mode is on the low end. Most folks like it to be around 80 degrees, it looks like, but then we got the people down here. Anybody have an idea why? Anybody want to text in?
Jeffrey Jones says, oh, where is this data set? Sorry, skiers? It was also his guess. Is this data set something that you've shared publicly?
Yes, it's under the Explore menu. I'm sorry, I sometimes move a little fast. I know there can be a lag, yeah. So if you go to Explore.
And his guess is, he found it. He said his guess for your question is skiers. Maybe those people are skiers.
Oh, skiers. Oh, okay.
Yeah.
Okay. Yeah. Well, I have a different guess, and I don't know, okay? But my guess is
and Kristen Freeman says it's Celsius versus Fahrenheit.
Exactly. That's my guess, is that people reporting things Celsius rather than Fahrenheit. So we have a lot of users of StatCrunch in the U.S., but there are other places around the world, lots of other places that use StatCrunch, and I guess we had some folks reporting that in Celsius. So I did have instructions there in the survey to report in Fahrenheit, but my guess is people just didn't read it that closely. But it's kind of an interesting data, kind of a little interesting story that you can tell here with this data set as well. So that's some of the example surveys that we're turning over. You know, we could compare ideal temperature across gender and things like that, even across age, if there's any relationship there. So we've got that sort of data that's coming in all the time. It's a great source of new data sets, timely data sets to work with. I suppose the ideal summer temperature is not too timely, but it's shortly after the summer is ending for most folks in the U.S. at least. Okay, so I've used these surveys. It's really changed the way I teach. More than anything else, this has changed the way that I teach. And so my classroom, we use StatCrunch every day. One of the things I haven't pointed out, but StatCrunch works on iPads, on iPhones, Android tablets, Android phones, BlackBerry tablets, as long as they still exist, Windows phones, and so basically any sort of device, from a laptop, desktop, to a mobile phone or a tablet, StatCrunch will work on those devices. And so my students, about half of them, will use it every day in class, as Aaron mentioned when we started. About half of my students will use it on a tablet or a mobile device, and the other half bring a laptop to class. But I have them in class do activities, report their results via the survey engine here, and then I can, in one single click, pull all their responses, all their results, put it up in front of everybody, and we can discuss it. So it's like a clicker on steroids in some sense, because clickers are typically, you get data that you can do a simple pie chart of or something like that in the context of your PowerPoint slide. But with these surveys, I get the data into the StatCrunch tool, so I can do lots of stuff with it. Much more interesting than a simple pie chart or bar graph that you get with the clicker stuff. So I want to walk you into my group here. I'm going to go back into my groups, NC State. This is a public group, so you can actually go through this as well if you want. You can find it by going to the Explore menu, choose Groups, and just search for NC State. Let's see, maybe not. Let me see what I named it here. Oh, NCSU, State, yeah. So Explore Groups, look for NCSU. And there's my group right there. So it's wide open, so you can step into the group if you want. When you create a group, you can make it private. You can force, I let anybody join my group. I don't require approval. You can set it up so that you have to approve everyone that gets in your group. You have lots of options there for how you can control the group. So as I mentioned before, these are some of the data sets I'm using in the class. There's a Big Bend data set. We've got several good data sets here. This is another resource that you guys might want to look at. These are the ones that I'm actually using in my class. The best one I think I've used in a long time is the stop and frisk data. So this is all the data from every single stop and frisk event in New York City in January of 2012. So I think there were 67,000 such events. And we have a whole lot of information about the folks who were stopped and frisked. We have their gender, their race, their age, their height, their weight, whether or not they were frisked or searched, whether or not they were arrested, whether or not something was found as part of the event. It's just a great data set, and it's got a lot of very interesting features. It's a great real-world data set. You need to clean it a little bit. I think that's something else that students need more experience with. So this is a great data set that you can come back to this group and find if you'd like to use it. The surveys, though, that brought me to the group here, these are the 11 surveys. So I've basically done one of these in almost every class period so far this semester except the exam period. Let me just click on this. So, you know, I have a student survey that they do right out of the gate when they come to the very first class, and we look at the data then from every student. What I found is that students are inherently interested in any data set that they're a part of. If they're a row in the data table, it makes all the difference in the world in terms of their attention. They really, maybe it's the narcissistic part of our society, but they really want to know how they compare to their peers. And so you're going to have a whole different level of discussion if you start looking at student survey data in class. And this is a very standard student survey here. What's your gender? What state were you born in? What's your age? How many credit hours are you taking? So we've got lots of information here, 16 total questions. And then I use this in several examples then throughout the semester. All I have to do, by the way, when I do one of these surveys in class, most of them, by the way, are not 16 questions in class. They're much shorter than that. All I have to do is I look for this red number to increase. This semester I have 80 students, roughly, and once everybody's chimed in, I see the number gets sufficiently large. I just click on the Analyze button, and all that data comes directly into the software. So now we can really start doing things with the data, like I said, things that you couldn't do with a sort of standard clicker approach. So we can start seeing how you know, the students compare in terms of credit hours and things like that. All right, so that's the simple student survey that I start off the class with. I have a pie chart survey here. So, you know, one of the things I like to tell students how to do good graphs, and one of the things I emphasize is why we prefer bar charts over pie charts. And this pie chart survey is related to an activity where students are trying to answer questions from looking at a set of pie charts and looking at a set of bar plots. And it's amazing how much more accurate they are looking at the bar plots compared to the pie charts. And this is a survey where I'm collecting data in that regard. We got a stop and frisk survey, so an activity related to that stop and frisk data. The Old Faithful survey, here they're supposed to pick the bin width they think that tells the best story with the Old Faithful data, and this is a really notoriously tricky data set in terms of picking the right bin width. If you pick it too small, it's all noisy. If you pick it too big, you miss the information, the most important information in the data set completely. And this activity, this Old Faithful survey where they pick the bin width after looking at the data on their device is really emphasizing that. We got some additional surveys here, mean versus median, a discrimination survey. These are all connected to some activities. I love to do hands-on activities in the classroom. Sometimes they do them individually or they do them in pairs, and then they enter the results from those activities into the surveys. We got a correlation guessing that I had them do for 5 different correlation pictures. Exam simulation survey, this is a randomization test that we're basically doing here where they do it once by hand and report their results. And then I pull all their results together into Statcrunch, and we see how unusual the observed result actually was, where they do that randomization approach by hand the first time around. So lots of different things here. If you're interested in the activities I'm doing that are connected to these surveys, I can certainly get into that with you. You can send me an email offline, and I can go into that in more depth. There's some really nice things. Mm-hmm.
Sorry, we had one question that asking if you'd be willing to share your class syllabus, and also wondering what text you're currently using for the intro course.
Yeah, okay. Yeah, I would certainly be willing to share the syllabus. I use my own notes, so I've done this for a long time. So I'm not using a text. I have a pretty detailed set of notes that I'm constantly revising, and that's what the students are using this semester. So I'm really experimenting a lot in my course. I've cut out homework. I don't have them do homework. We do a lot of activities and things like that in class. I encourage them to interact in class, and I'm experimenting with sort of changing the paradigm, the way that we think about running the intro course a little bit, and trying to really figure out what works and what doesn't work, at least for me as an instructor.
Are your students buying? Sorry, are your students buying your notes, or do they get them online?
I give them the notes, yeah. I give them the notes. So it's basically a set of keynote or PowerPoint types of notes that they print out, bring to class, and then annotate. I have spots clearly left open in the notes where they're supposed to fill in information and things like that. So I require attendance. You know, they're severely penalized if they miss more than 2 classes. It starts impacting their grade immediately. I want them to show up. I want them to pay attention. I want them to interact. I ask for their time, the 3 hours of time that we're in class. I want them to be active and attentive in that environment. And so I sort of cut this deal where we're not doing homework anymore. I want them to focus on coming to class, paying attention there, and not sort of the busy work of homework. So far, so good. I did this last semester, and it was an interesting experience. I don't know that I would recommend it for everyone, but I think for my approach, it's working pretty well. So as I said, if you're interested in these activities and the surveys that go along with them, I mean, it can really change the way that you teach. Instead of you doing all the talking, it's going to change the complexion of the classroom completely. It's going to be much more interactive. And I think if we're going to continue to get together for live class meetings, we should be doing more things like this. We've got to there's no reason for people to show up and have one person do all the talking. And what I've been amazed by in this experience, by the way, is how much students can learn from each other. So when we step out and we do these activities, sometimes like analyzing data in Statcrunch, when they're doing it together, working in a pair, they'll figure things out. They'll ask each other questions that they might be sort of apprehensive of asking of me in class because of you know, the sort of shyness, I guess, that a lot of students have of openly asking questions in class. And that's been a big learning experience. That's a big part of the learning experience, is letting them have the chance to talk about this stuff together, to practice saying statistical things to one another. And then oftentimes when they enter their answers into one of these surveys, I'll use Statcrunch to randomly pick one of them, and I'll ask them to explain to the class how they came up with that particular answer. I've really enjoyed this. This is, like I said, changed the way I teach more than anything else. And it's that ability to get input from the students directly and then analyzing that input in the classroom with a single click that makes a big, big difference. Okay, so, you know, Statcrunch has a lot of stuff here. You got the software tool, which is what most people think is sort of synonymous with the word Statcrunch, that I spent a great deal of time showing you. You got the groups that you can form for your classes. You can share data sets, results. The other thing you can do is reports. You can actually have your students do a report where they use Statcrunch to analyze data, save results, and they can put the results and the data along with their own words, put it all together for a nice online report. My students will do one big project report this semester. I did this last semester, and it was one of the most reaffirming experiences I've had as an instructor. I felt like my students seemed to really enjoy the experience. I asked them basically to find data that interests them and tell a story about it using statistical graphics, statistical summaries. So it's very descriptive in nature, but they'll do a project report like that using the reporting tool in Statcrunch a bit later in the semester. So you got the reports and the surveys as well that I mentioned. So there's lots of different types of things you can do on the site. It's not just statistical software, but all those things rolled together. Data collection thrown in there as well. I know what a lot of instructors are doing now, and a lot of my students did this last semester for their project report. They actually created a survey. They've done so many of them in the classroom, some of which I generated on the fly in the classroom. They saw how to do it. So they actually constructed surveys, and they floated those surveys out on Facebook and Twitter and collected data from their followers there, and then summarized that data. It was on a topic of interest to them, so it gave them a chance to actually design the survey, collect the data, and summarize it as well. And I know a lot of other instructors around the country are now doing that as well. Now, let me just take a couple minutes. I want to have some time left over for questions here, but we had a question about the Facebook application. There's a Twitter application. There's Statcrunch U, it's a virtual population that you can sample from. There's lots of these sort of apps that are, many of them have a teaching focus to them, that are available under the Resources tab. So you have Facebook Friend Data, the Twitter app, Statcrunch U. Statcrunch, this is a cool tool. It's a bookmarklet that you can install on your bookmarks bar, and then when you're browsing the web, all sorts of data lives on the web. You see a data set on a web page, you can click that bookmark it, and it'll automatically go through that web page and pull the data into StatCrunch. That's probably one of the flashier things I've ever created is the StatCrunch this bookmarklet. But I think what I'll do, since we had a question about this, is show you the Facebook friend data app. Let me come over here. So when I clicked on that, I've already logged into Facebook today, which is rare for me, by the way. I don't hardly ever log into Facebook. But what just happened here is, hopefully your screen gets updated pretty quickly. The information on my 142 Facebook friends is being pulled into StatCrunch. And it's actually pulled in here. This is we haven't converted these resources to the new version yet. So we're going to be doing that over the remaining part of this semester. But so come in the spring, this will be converted to the new version. Now it's still the Java version. But you'll see exactly how it's going to work in the future by working with this. But so my 142 friends are now each a row in this data table. I can go over here and look at some basic summaries, like I can look at the gender. I see I have a few more male friends than female friends. I can look at their relationship status. Of course, students love this. So this is the tool I typically use on the very first day of class. I sort of challenge the students to see what they can learn about me. What do they know? What can they learn about me from looking at my Facebook friends? So by going through the data that I'm showing you here. So in this case, the married people are eating everybody else in the pie chart. And of course, I should show you this as well, so students think, oh, I want to identify who my single friends are. So they can actually do that by selecting that wedge of the pie chart. So my goal with this really is to have the students think about, wow, data's around me, and if I look at it the right way, I can actually learn something that interests me. Maybe I want to find who my single friends are or something like that. You can actually see their pictures over here to the left. So if you're looking, I suppose. And then what else? So I'll turn off all that highlighting. Let's see here. You can look at their birth month, their birth date, their age, and this is always interesting. So most people, when they look at this app, they find that they are the mode of their Facebook friends' ages, and that's in fact true for me as well, 45. The location is the interesting one. This is what I was talking about. So if you think about what location is in this data set, let's see. Sorry, I just went past it, I think, or maybe not. Yeah, so this is the location column. So it's like Tampa, Florida, Huntersville, North Carolina, Bowling Green, Kentucky. So you see just a bunch of locations like that. And oftentimes I think even many people who teach that don't think about that as really being data in the classical sense, but it most certainly is. And you can actually look at this geospatial distribution of these locations by using this location link here. So what happens when you click on that is what StatCrunch does, it takes each one of those locations out of that data table, goes over to Google and says, geocode this location. So give me a latitude and longitude. So if you really think about it, what we can do is convert that text data, those locations, into lat and long, into numerical quantities that we can then plot on a Google map. And what it's doing for the 133 of my friends that actually provide a location, it's going through and doing that geocoding and putting an individual bubble on the map where that person is located. And it speeds up. It does cache things, so you'll find that you do have a lot of friends in the same location, so that it just has to geocode that location one time. And so it will speed up. Google limits you to one geocode request every half second. So if you do have 500 or 1,000 Facebook friends, it'll take a little bit longer to actually generate this picture. But once it finishes, some really cool things happen. It clusters. You know, so you have a lot of overplotting in the original individual locations. And what it does, what StatCrunch does, then is it clusters that information. So we can actually drill in here. We can see that I have 23 friends in the Southeast, 43 out in the Midwest, where I'm originally from, I guess. Then 18 or so, probably mostly Pearson folks up in the Boston area. Well, actually, no. It looks like there's more in New York maybe than Boston. So I can drill in and see exactly where all these friends are located. So you can almost follow me around the United States. I was born in Arkansas. I have 19 friends that are still living there. I have 15 friends in College Station in the Texas area where I lived before moving over here to North Carolina, to the Raleigh area to come to NC State. You can click on any of these bubbles and actually scroll through and see all the friends that you know there. So a lot of my students have written me back after the class and say, wow, I really used that Facebook application when I was traveling to see who I knew in the location I was going to. And this is even a more rich application for students. The average student has over 500 Facebook friends when they enter college. And so it's really a way for them to learn a lot about this group of people that they may not actually remember that much about. It can be an astoundingly large number. So this is a unique tool. It's a different way of looking at data, and it's really meant to be a tool that gets students excited about data. It's a data set that interests them. It's about them when they load it, and it's something that's really designed to pique their interest, get them interested in data very early on in the semester. So with that, I think I'll stop. If you guys have any questions, I'll be more than happy to answer them.
Thanks so much, Webb. We'll give folks a couple of minutes if you want to chat a question to me or to the group. You can ask Webb directly. Jeffrey Jones says this was awesome. All caps. Very excited. It is really cool, thank Webb for talking about all the ways he uses it in his classroom, because I think that's really valuable for folks. Jeffrey Jones asked if you would be willing to share your email address. I'm happy to send an email to everyone who participated today with that information, Webb, unless you want to share it now.
Fine. Yeah.
Okay.
Yeah, that's fine. Yeah, it's just websterwest@gmail.com. So.
Pretty easy. Great. Yeah, Jackie Johnson's great presentation, very helpful. Jeffrey Jones says he can't wait to bring it to his classroom. Jane Marie Wright is asking if you will be at AMATIC this year, and I know that you will not be. Is that right?
Right, but one of the other StatCrunch developers, Nathan Torno, will be there.
Yeah, Nathan Torno will be there.
Yeah. And Nathan specializes. Yeah, he specializes in the applets. So if you have questions about applets, Nathan is the guy to go to. He's been in charge of the conversion from most of the applets from the Java version to the new HTML5 version that I showed you today.
And he's also one of your students, isn't that right?
Yeah, Nathan started working. I was his instructor at Texas A&M, and then after he graduated, I hired him, and he came to work for Integrated Analytics, which is the company that produces StatCrunch.
And he's also used StatCrunch in his own classroom.
He has, yeah, and he still teaches part-time. Yep.
So we are having a reception for StatCrunch at AMATIC where we will be doing a demo, and Nathan will be there to walk through StatCrunch and answer any questions. So Jane Marie, if you're going to be there, I'd be happy to send you that information if you'd like to join us. I believe it's Friday evening for the reception. November 1st, I should clarify. Oh, Jane's already signed up. We're good. Great. If anyone else is interested as well and is going to be in Anaheim for AMATIC, just let me know. Will you be at TCCTA, Webb?
Okay. I need some help with that acronym. I'm not sure if I recognize that one.
That is a good question. I recognize it, but I couldn't tell you what it stands for. That came from Jackie Johnson. Jackie, could you clarify when and where TCCTA is?
Texas Community College?
Texas Community College Teachers Association.
I'm not sure. I don't think I'm scheduled to go to that one. I am going to be going to ICTCM, which is in San Antonio, in March. So I will be there. That's quite a ways off yet, but I think that's the next thing I have scheduled in Texas.
It'll be February 21st to the 23rd in Houston.
Ah, okay. No, I'm not going. I don't think any of the other StatCrunch developers are going. Aaron may know better than me on that one, but.
Yeah, Jackie, I'll certainly check on what Pearson's presence will be at that conference, and if you're interested in having some kind of StatCrunch part of it, we can work something out. Michael Abrams is asking, is there any manual that lists the StatCrunch features?
There is a help page here. Let me just click on that. One that we're going to actually update This is sort of an older look and feel. We're going to spend some time, once we get all the conversions finished up, every little nook and cranny, we're going to come back over here. But this is sort of clicking on the help link will give you an overview of the things that are there. And if you click on any of those links, you can actually get some detailed instructions on how to do things. For summary stats for columns, for example, here's the blurb that we have on that. Moving to this new format, when we're in the Java version before, it really limited what we could do with the help system a bit, and now the door has been opened. So once we finish this conversion, we're going to be actually embedding videos and more graphics, screenshot type things in this help, rather than relying on the YouTube channel. But the YouTube channel that we have, which you can access by clicking on the YouTube link on any of the StatCrunch pages, it's right here. Over in the upper right-hand corner, there's several 50-something videos there where people show you how to do everything in StatCrunch. It's not a listing, but if you want to just sort of peruse those, I think it's an excellent resource. The channel is actually embedded here, and this is my intro video that starts it all off, but you can actually go to that resources page, and by clicking play there, you'll actually see some of the videos that start coming up in a carousel fashion at the bottom. So those are some places that you can go as a reference for more information about StatCrunch and its capabilities. Be on the lookout for a severely updated, I guess would be the way I would say it, help facility that'll be coming along in the spring semester.
Michael says thank you. Give folks a couple more minutes, a couple more seconds, I guess. I want to thank everyone also for joining us. I know some people had to, sounds like, log off a little bit earlier, but we really appreciate your attendance and hope that everyone learned something new.
Yeah, and all comments or questions are happily, we like to take feedback. Instructor feedback has had a big impact on our development process. We're constantly getting requests, trying to meet those requests. For example, the calculator thing, we had that request 2 weeks ago, and we were able to really quickly put that together so people could save the results of those calculators and turn them in as part of homework and things like that. So anything that you think that could be done to improve the package, we're always listening, so please let us know.
Great, and Joe's also asking, where will the recording of this session be located later? And I think our plan, Web, was to post it on the YouTube channel.
That's right, yeah. We'll put it close to the top of the YouTube channel. That's right. So if you just click on that YouTube link on the StatCrunch pages and go to the channel, you'll see it near the top there.
Great, thank you.
We'll be doing another one of these. I think Nathan does one next week, right? Then I'll do another, and so we'll actually try to keep a library of those up on the YouTube channel. So Nathan will probably cover a completely different set of items whenever he does one next week.
He's doing one. It's 2 weeks today, so we have
2 weeks.
Yeah, every other Friday, alternating the time as well. Yeah.
Yeah, so Nathan will probably do a completely different set of things, and his probably spend more time on the applets talking about those, since that's where he spent a lot of his time.
Okay. I guess with that, we'll wrap it up. I will send an email out to the group later today to thank everyone, and so that you have my contact information as well, in case you need anything or need to get in touch with Web. All right. Thank you so much. Everyone have a wonderful weekend, and Web, thank you for taking the time to do this today.
All right. Thanks a lot, guys.